phases. You say, what are you going to talk about, Bill? The phases of the moon? No, we had a problem the other day because I presented the following. Okay, let's start at the beginning. I said, and this is just a synthesis, I said that we have the universal movie. Okay, universal movie means that every frame that you're staring at there is just locations, just distance from one object to another. There's no motion whatsoever in each one of those frames. Okay, I can put a solid anything you want there. I can put a table, for example, and that's a solid. We call it a solid. I don't need to have the table moving for it to be a solid. Same with liquid. I don't need to have liquid running down a hill. I can have just a puddle of milk on the floor and call it liquid. I can say liquid. Point and say liquid. It didn't move, but I can label it as liquid. And the same goes for gas. Gas does not need to move. I can take a snapshot of an astronaut releasing gas in space. I take a snap, it's color coded hopefully, and I take a snapshot of that. I've got gas there. I call it a gas. Could be smoke, could be anything. I showed some examples the other day. You can't do that with plasma because plasma is defined as a process of ionization. You need to have 2 frames of the film, at least of the universal film, in order to see before and after. Okay, meaning in the case of quantum mechanics, that the atom is whole, and in the next frame it loses an electron. We call that ionization. Something happened to the atom. That happened is called plasma. Plasma is not the end result. A snapshot that you take after it lost its electron or gained an electron. That's not plasma. Plasma is a constant process where some atoms haven't even lost anything, but they're part of the soup called plasma. Some lose, some gain, some are neutral, and you have this entire soup all together. If you take a snapshot of that, you don't have plasma because plasma is the process of ionization. And I don't know how.
Why is it important if you call plasma a state, a phase?
Okay,
it seems like stamp collecting.
It is, and it ain't, because then they've discovered so many other. One guy said 18 different types, and I mentioned a few the other day, of states of matter. And the question is, can you compare a plasma against a solid? Is that a fair comparison? Are we comparing boy running against boy? That's the issue. Okay, so and that creates problems because when we have a single frame in the universal movie, we can point and say, this is the object that I'm going to be using to do this or that in my theory. So I identify the object first. So I say, that's a table. Okay, table. It's not moving. It's in one frame of the film. Then in the movie, I have the table jumping up and down, throwing it over a mountain, whatever I want. I can't do that with plasma. I can't show you plasma to start out with and say, that's plasma, and I'm going to do something with plasma, which is what these people do, especially the electric universes. You can't do that because it's already moving. Plasma is a concept, not an object. It's not a thing. It's a thing in motion.
Like
and
fire.
It's the in motion that's important.
You're equating it to fire.
Exactly. And that's, in fact, one guy said that. Said that plasma is just fire. Okay, so here we have a situation. One file says, go ahead and read if you want.
So I am imagining an analogy for when you say single frame of the universal movie. If I were to compare the universal movie to a rope and cut a very thin slice, it would still be a measurable thickness, and I could cut it thinner. But I don't think it would be possible to ever conclude you have a single frame of a continuous object. Now, wouldn't that analogy also be true for time? You can't cut thinner slices, but never truly a single frame? Even a camera has an exposure time.
So what's the issue? The issue is this fellow doesn't understand what the universal movie is, what the concept of the universal movie is, or what it's used for. This is what he's saying. He's saying, look, if I take a continuous object, such as a rope or any elongated object, he says, he stretches it across 3 frames of the universal movie. He says, I can't put a continuous object or an elongated object in one frame because it stretches all the way to all these other frames. And again, he's not understanding what the universal movie is saying. Yes, hopefully we can put an elongated or continuous object in a single frame. And here's a proof, evidence, okay? There, we put the whole single thread that we have underlying our theory, right? Or actually the hypothesis. And you see it in a single frame, okay? The whole thing is in one frame. It doesn't stretch to the other frames in the movie. Because again, the universal movie is a concept that says that anything within a single frame is an object, a thing. It has no motion whatsoever. Okay, that's the first part. But here's another fellow, and he comes up with this. He says, all liquids, solids, and gases are in a rapid state of motion if you zoom in close enough. There's no such thing as a still object. In other words, he's saying that the electrons in his film are moving, okay? But see, we have to distinguish the film he's got in his hands, which he doesn't realize this, versus the movie that we're talking about. The universal movie says that in the frame, nothing moves, not even an electron moves. Everything is static. Everything has distance with respect to everything else. Everything only has location. Everything only exists. And he doesn't understand that. He thinks that, oh, the electrons are always moving. Yeah, they're moving in your film, not in God's universal movie film. Okay, so we have to distinguish one from the other. And I'm not sure.
He just doesn't know the difference between a frame and a movie.
Yeah, he thinks that he holds a film in his hand. He said, well, but the atoms that make that frame of the film, they're moving. The electrons are moving in there, Bill. Yeah, I know. No kidding. We know that because that's not what we're talking about. We're talking about the universal movie where we're saying all we have is cross sections of location, distances. So in any frame in that movie, in the universal movie, we'll call it God's movie if you want, every frame only has location. Every atom in the universe, every electron, everything just has distance, static distance, location, nothing but. So you can't say, well, the electrons are moving. No, not in that frame. That's not the same frame that you have in your hand, a little bit of film that has made out of atoms and whose electrons move around. Those are two different things. So I don't know if I got through to him, but I tried. Okay, so this is our universal movie. Okay, every frame here, when you look at frames 1005, 1006, 1007, everything just has location within each frame. There's nothing moving in the frame. That's the entire universe there, every bit of matter. Nothing moves with respect to anything else. Okay, so that's what we're saying is the universal movie. I hope someone out there understands what I just said.
If you ever make a movie, call it the Universal Movie first.
That's why they call it Universal Studios. They do that.
Yeah.
Okay, so this is God chopping time. That's what the universal movie is all about. So one frame is the present. It's where the past and the future meet. The present, the now.
Well, it doesn't have to be the present, though.
Well, I call it, I mean, we use the word present to say it's where the past and the future meet.
What I mean is you could be talking about a hypothetical or something that happened in the past.
Yeah,
you could be ripping a frame out of somewhere, and it's not necessarily the present.
Okay.
I think the present is confusing because the present is always a movie.
I see. Okay, but what I'm saying is that frame where the past and the future meet, anywhere where you cut that, we'll call it the present. Okay, we'll just call it the present. It's just a name. And we're saying that only has locations, set of distances, and existence, all static concepts. Okay, there's no motion right there where God chopped it.
In one frame.
In one frame.
The whole purpose of the frame is to be able to analyze.
Exactly. It's to be able to talk, especially to identify the objects that you're going to use. People have these things running and say, oh, but plasma. No, you can't put plasma in that single frame. That's the problem.
It's a good way to distinguish where the shapes of things are, i.e. the objects are, because they're not moving. You can't confuse its motion or its what do you call it? Ellipses.
Ellipses.
You can't confuse its orbit. There's no picture of an orbit, so it's a good way to just say if you take a picture of it.
Orbital, for example.
Yeah, you can't take a picture of an orbital, but you can take a picture of what is orbiting.
Right. And so what we're doing is cutting all the noise so it doesn't bother you. Okay, we're trying to cut down on the noise. Okay, so here's what we see. That's frame 1006. What do we have there? We have only distance, existence, and location. All three are static concepts. There's no motion. There's no orbiting. There's no plasma. No time.
No fire.
No fire, no time.
No falling.
Only distance, location, and existence.
There are no concepts. I mean,
right.
I mean, no, sorry.
No, dynamic concepts.
Yeah. You split them up into dynamic and static concepts. Because you can have distance in a picture, but you can't have jumping.
Or displacement.
Yeah.
See, displacement is what mathematics uses because they measure everything. And people say, well, what's the length? Length is a static concept, isn't it? Yes and no. If it's qualitative, it's a static concept. The length of mathematics is unrolling the measuring tape. And they tell you 1 meter. What is 1 meter? That means they unrolled a measuring tape full of little tiles. Okay, so they count tiles. That's not a static concept. Okay, so nothing in mathematics is static. Everything is in motion. When they talk about geometry and they say, look, here we have a cube, as long as you talk about length, width, and height, qualitative, no problem. But as soon as you start measuring, talking about volume, for example, or the sides of a cube, for example, and they're talking about meters or feet or whatever. Now they're measuring. Now they're unrolling the measuring tape. No longer is it a static concept. There are no static concepts in geometry, in mainstream geometry, because it's all measurement, and measurement is motion. And there's no static concept in mathematics at all. Every equation, it represents motion. That's what an equation is. You plot one point, you change a variable, put another point, another point, another point. Now you know how the deer ran. That's what it is. There is no equation that has that represents a static concept. Especially, you don't have an equation that represents, I don't know, a plane or a solid or any of those, even a line. We're talking about the stick, not about the measurement of the stick. Okay, so we have to distinguish those.
Not a number line.
Yeah, a number line. Yeah. Okay, so what are these people referring to? They're referring to what are known as phase transitions. Okay, and you have enthalpy there. That what you have is increasing heat. Okay, and what it is with the same pressure. Okay, and all these are essentially what you see there: phase transitions. And repeat that phrase in your mind every day now, phase transition, because they're not talking about solid, gas, or liquid. They're saying, look, this is how a solid converts to liquid if you heat it, and it converts to a gas if you heat it, and it converts to plasma if you heat it. Those are phase transitions. Those are not solid, liquid, and gas. And so here, let's take it one step further so that you see what I'm talking about. Okay, let me get rid of this one here. And yeah, if I can heat a solid and turn it into a liquid, liquid into gas, what are we going to call the intermediate steps there? Do we have a name for those? The solid liquid? Is that what we'll call the one between solid and liquid? How about the liquid gas? What do we have in between where we had the transition? Do we have a name for all those? So we have to distinguish the transition from the state. Plasma, like any phase, is a transition, not a state. State is a static concept. Transition, what is it?
That makes a lot
phase.
of sense.
Those are all dynamic concepts. Those involve motion, time, etc., etc., etc. So what you got to do is figure out what you're gonna call the ones in between.
So you're saying plasma is a phase.
Right, it's a phase, it's a transition.
That makes sense.
And because you have to have time and motion and 2 frames of the film. Of the universal,
to compare non-ionized
before and after, because you're going to have the atom again, and then in the next frame the atom loses an electron. So there's a transition, and it's the transition that's called plasma, not the end result, because the end result again includes atoms which have not lost their electrons, atoms that have gained back an electron because there's a recombination, and then you have atoms that lost their electron completely. And this soup, ongoing soup, is called plasma. Okay, no such thing as static plasma where you can point your finger.
Plasma.
As soon as you freeze everything recombines back again, and you have gas, not plasma. Okay, so here it is. Phase is not a state. State of the Union, state of Arizona, none of that. Okay, phase, a series of events, process of change. Those are the definitions for phase. Okay. Phase of matter, one of the distinct forms in which matter can exist. Absolutely not, because phase and exist are contradictory terms. What is exist? Physical presence, no motion in any of those 2 words. Physical requires an object, again, no a thing, no motion involved in the definition of thing. And location, again, no motion involved in location. So a phase of whatever is not exist. Not a synonym of exist. You can't define it in terms of the word exist. Exist is a static concept, and the definition of exist contains no provision for motion. You do not need time, for example, to define existence. When I say this exists, are you saying this exists in time, over many frames of the universal movie? No, we're saying it exists means it's an object and has location. So it's a static concept that falls in a single frame of the universal movie. Okay, so here we have the rundown. This is location, set of distances, and state is a synonym of location, condition at a specific location. That's what state is. What is motion? In contrast, more than one location. Okay, you need two, at least two. Like in the example below, you see an atom with the little electron orbiting at one place, and in the next frame, the electron is another place. Okay, so you need two frames of the film to show that an electron moved. Otherwise, you have location, just the um, electron at given distance from its nucleus.
Actually, that's a good question. But if
Uh-huh.
you zoom in enough to atoms, can you even tell what state they're in?
No, they could never. They can't even like Atom Man. You mean like if Atom Man went with
Yeah,
his
if
camera?
you go in and you see each ball, for
Well,
example.
again, okay, and I take that. I use that example. I said, take Atom Man. He's small enough,
Yeah.
right? He's got his camera, right? He goes down there, takes a picture. Whatever he takes, let's assume the atom is what quantum says. You know, a little bead that goes around the nucleus. Fine, no problem. He takes a snapshot of that. Could take it also of the cloud, the model, et cetera, et
Yeah,
cetera.
whatever he takes a picture
He
of.
takes a picture. Now he brings it back. That picture, forget about the electrons that are moving within the atoms in the picture. We're talking about the picture, okay?
Yeah.
That one is a still image.
Yeah.
So whatever you got there, the electrons on this side or on that side of the nucleus.
Yeah, but that one,
Period. We're
can
done.
you tell that it's a solid, gas, or a fluid? I think not.
I,
right?
well, I mean.
If you take a picture
Uh-huh.
of two atoms next to each other,
Okay. No.
there's no way of knowing. Let's say they're both hydrogen atoms, right?
Yeah.
If you zoom in close enough, you can't tell if they're fluid, if they're
If they're moving.
gas. No, you can't tell what state they are.
Well, yeah, you can because all you have is distance in the
Yeah,
photograph.
yeah.
And I zoom in, zoom in, zoom in as far as you want. At some point, you're just going to get distance.
Yeah.
Because the other atom's going to be over there.
But with the distance, you can't tell what state it's in.
But I mean, distance is a static concept, and if in your picture, conceptually, right?
Yeah,
in
yeah,
your
yeah.
picture, they have a specified distance separation, not measuring, but
Yeah,
Yeah,
they're not next. They're not the same.
right.
They're two
then,
next to each other,
then
but you can't tell
You have a
what-
static image.
Yeah, but you can't tell what state they are.
A state meaning what? State is
If it's a
synonymous with
liquid,
location.
if it's a gas, if it's a solid.
Well,
That's what I mean. You can't tell if it's either of those.
I'll give you a better example than that. I take a snapshot of milk on the floor.
Yeah.
And I show it to the ET. He doesn't know what milk is. He says that's a solid because it's standing still, right? And so I took a picture of something which is a liquid,
Yeah.
but because I took a picture, I kind of solidified it in a way that it's
Unless
not
you have
moving.
prior knowledge of what's in the picture, you can't tell if it's a liquid
Right.
or not. That's true.
What we do is we just say, I don't need to have milk running down the hill. I see a puddle of milk on the floor, even if I take a snapshot of it or whatever,
'Cause we
and
have
I show it
prior
to someone,
knowledge.
yeah, and we say, what is that? That's a liquid.
Yeah.
That's all we say.
Psych, it's frozen.
Yeah.
It's frozen milk, but it just looks the same.
Yeah,
There's no way in hell. There's no way
it
of
could be.
knowing.
It could be frozen. It
Yeah.
could be a solid. But that's why we have these categories for what we're pointing at, right? Okay, exist, object plus location. So state is what? A condition of existence. That's what it is. And there you can see exist, nothing moving in that single frame. On the other hand, time is not the same thing as existence. You need at least two locations, more than one at least. And time, like motion, requires at least two frames. Okay. So neither what is it? Neither time nor motion are synonyms of state. They're synonyms of phase and vice versa. State is neither motion nor time. It's location and distance and existence. So that's essentially it. And here's the final picture, summary, I guess you could say. Okay. Location, set of distances. State is a condition at a specific location. That's what a state is. What is a phase? A process of change. Okay. For example, ice turning into water. Okay. That could be a phase. Okay. You can say
It's phasing.
yes, phasing.
It's plasmaing.
And what are you going to call the intermediate transition condition? We have no name for that. We say, well, ice turned into water.
The objectification of concepts is really weird when people point to fire, or point to shadow, or point to plasma. These things really muddy the water, don't they? Is
They
that why
do.
you're so adamant about them?
I'm adamant because people confuse objects with objects in motion.
With processes.
That's essentially it. I always give the example of kangaroo versus jumping kangaroo. Plasma is a jumping kangaroo. Ether is a jumping kangaroo. Okay.
Does light fall into that same?
No, because
the rope isn't light. Light is the torquing of the rope.
Both. That's the issue.
both?
Because we use the word light to refer.
Interchangeably, yeah, but
No. This is what I'm
technically
saying. I'm saying the following. I'm saying light is used for both, for the entity and the motion of the entity, because we've never separated. In other words, light.
But
We've always talked about it
yeah.
in terms of energy. Energy is a dynamic concept.
Yeah.
So we say light is the signal.
yeah.
But nobody ever said, well, what is the object that mediates light? And
Yeah.
and even then they say it's a bunch of particles that are flowing. They never show one particle, one photon, and say this is a photon. And I'm in the next 2 hours I'm going to explain how it moves. No, they never point to one. They just say light is flowing particles. They already go to the movie and they jump or they skip. You know that first frame of the movie where you point to the object.
But technically, light is a process. The torquing of the rope. Rope is that which mediates light. It isn't light itself.
It's both.
It's gravity.
It's both.
If anything. I mean, no, gravity is also a relationship between.
It's both because we've never qualified it in terms of what is the object that is doing light. That's
but isn't
mediating
it
light.
just easier to cut it? Like, why say both? Because it's not the rope itself.
I like to say both because I like to start always my films at frame number one, and people always start with strips with a whole strip of film. And I don't want. They already say it's flowing particles.
Yeah.
No, I don't want that. I want you to show me one particle.
The
so
first
that
one.
Yeah.
How did
so
the movie start?
How did the movie start? Okay, so that's the issue.